Hello, in this video I'm going to show you how to configure DHCP server plus DHCP relays and static routes. So we're going to work out this scenario together, and we'll try to fix at the end, make sure that host 1 and host 2 will be able to reach each other, as well as the servers which are located on this LAN. So first, let's see how many routers we have in this scenario. We have 4 routers: RT1, RT2, edge router, and the ISP router. Now, RT1 connects to this LAN 172.16.0.0/24, which is gigabit LAN. RT2 connects to LAN 172.31.0.0/24, which is another gigabit LAN. Both routers connects to the edge router through point-to-point links or serial link, like this. Now, the edge router connects to the ISP router through serial link, and the ISP router connects to 2 gigabit LANs which host servers like web server 1, web server 2. At the end, host 1, host 2 should be able to communicate with web server 1 and web server 2. But before that, host 1 doesn't have any IP address. Okay. Host 2 also does not have any IP address. Okay, so if I try to assign IP address, for example, there is no static, or they will get the API IP address. Same thing for host 1, they will get an API IP address, since no IP address is configured. Now, if you want to learn more about API, just check one of my previous videos on API IP addressing, automatic IP addressing. So what we should do, the first thing is to configure the DHCP server. So we have to configure the DHCP server. I go to the edge router, and this DHCP server should provide the IP address to this host on this LAN as well as hosts on this LAN. So it should be able to service hosts on these 2 LANs. So I go to the edge router. Okay. Now, edge router, I can see all the, I pre-configure the interface already, so something like this, to gain time. Okay, and you can see that serial 000, 001 and serial 030 are already configured with IP addresses, and all the interfaces are up, operational. And you can check also the the routing table. So there is no configured routing entry, or only connected routes. So the first thing I will do is I will start configuring the DHCP server. So the first thing I do, IP DHCP pool, and the name of the pool I will give is 172.16.0. What does this mean? It means that this pool is intended to service hosts on this LAN 172.16.0. So I will specify a range of IP address 172.16.0.0, the subnet mask. Okay, and the default router will be 172.16.0.100. In fact, this is the default gateway for all hosts on this LAN. So I finished configuring the first pool of IP addresses to service this LAN here. Now I will configure the other pool. This pool, I call it, for the second LAN, I call it pool 172.31.0. And here I show the range of IP address 172.31.0.0 with a subnet mask. And the default route should be 172.31.0.100. This is default gateway to be sent dynamically also to host requesting IP address or network parameters from the DHCP server. Of course, we can do something once we're done with the pool, configuration of pool. We can exclude, we can go here, DHCP, excluded, we can exclude some IP address. Now, in my case, now in this scenario, I will not exclude range of IP address. I will go for a single IP address, but if you want to see how to exclude range of IP addresses, you can check my previous video on DHCP. So here I will just use one IP address, which is the IP address assigned default gateway. So I don't want these IP address to be included in the pool of IP address to be dynamically assigned to computers, something like this. And this one also, I will remove it from the pool of IP address to be dynamically assigned to hosts on this LAN. So because it's already fixed, and should stay fixed, assigned to the interface of RT2. Okay, so now once I'm done, I just display the configuration. These are my excluded IP addresses, and these are the pool of IP addresses that I just configured. Now the question is like this: this edge router is already configured with the DHCP server. Now let's go to host 1. Okay, and from host 1 now I select the DHCP and see what happens. Okay, so normally host 1 should contact the DHCP server to get IP address from the same DHCP server, but what we see that host 1, it's like host 1 is not able to contact the DHCP server. That's why host 1 is assigning a APIPA IP address to itself. And the APIPA IP address should always start with 169.254. Same thing with host 2. Okay, alright, so if I configure again DHCP, so which means that I'm asking host 2 to contact the DHCP server, and same thing, host 2 was not, the request was not successful, so APIPA is being used here. Again, you can check my previous video on APIPA, which is very important. So which means that host 1, host 2 don't have static IP address. They are not able to communicate with the DHCP server to acquire IP addresses dynamically. So the only solution now is to assign themselves to get assigned the automatic IP address from APIPA range. Now this is, what's the problem? The problem is like this. In DHCP protocol, when host 1 starts communicating with the DHCP server, the first thing it will do is to send a discover DHCP message to discover, and this message is broadcast. It's layer 2. It's broadcast at layer 2 at MAC address. Now this type of broadcast will be stopped by the router. So a router will act as a barrier. I mean, it will not allow any broadcast packet, layer 2 broadcast to cross it. So it's going to stop it, which means that DHCP message, discover message will never make it through RT1 to reach the server. It cannot. Same story here with host 2. Host 2 is going to send DHCP discover message, which is broadcast at layer 2, and this broadcast also will be stopped by RT2. So if you want to know more about DHCP, how it works, and the protocol itself, just go to one of my previous videos on DHCP protocol, because it's very, very important to understand how protocols work before you jump into configuring these protocols on routers and switches. Now, having said so, what we can do, we're going to ask router RT1 to act as a relay for this broadcast message. I mean, it should provide some help, since the broadcast message sent from host 1 to discover the DHCP server cannot make it through RT1 because it's broadcast, and RT1 acts as a barrier. So RT1 is going to help that packet reach the server. So in order to help, we're going to go to RT1. Okay, I go to the interface gigabit 0/1, and the first thing, let me just show you the RT1. I already configured the RT1, the interface on RT1 with IP address, and they are all operational. So we have this gigabit 01 and the serial 000. So what I do now, and the same thing with the routing table, there is no configured routing entry, only connected route. So what I do, I go to the interface gigabit, interface gigabit Ethernet 0/1. Okay, and this interface, I instruct this interface that each time you receive a DHCP packet broadcast, okay, a broadcast DHCP message like discover, just use the you help it reach the destination, IP helper. So you just help it reach the destination, and destination in this case will be the IP address 10.0.0.2, IP address of the serial 000 interface of the DHCP server. So I put 10.0.0.2. Okay, so I have done this. Okay, I am done now with RT1. I will go now to RT2 and give it the same instruction. But before that, I will show you the interface brief here. Show IP interface brief. This is to show you that the interface are already pre-configured, which is gigabit 0/1, gigabit Ethernet 0/1 interface, and serial 000 serial interface is already configured and operational. So now I go to the interface which will receive a DHCP discover message, which is broadcast. This should be interface gigabit Ethernet 0/1, and then I instruct this interface, whenever you receive such a broadcast packet, help it reach the destination address, the DHCP router, through IP address 10.1.1.2. Okay, 10.1.1.2, which is the IP address of the other interface, serial 0/0/1 of the DHCP server. So after we have done that, okay, it's fine. Now everything is fine. Let's go to host 1. let's go to host 1. Okay, let's make it now static, look like static assigning IP address statically, and then go back to DHCP. Now host 1 will try contacting DHCP server, since we configured this router to have the broadcast message reach the DHCP server, but still we still have the IP address here on the host 1. And what about host 2? I can do the same thing. Host 2 is trying to contact the DHCP server, but still IP is going to be used, as we see now. Why? The problem is very simple. RT1 is directly connected to this LAN as well as this LAN, so it knows how to reach both LANs because they are directly connected to it. Same story with RT2. Now, the DHCP server is configured on this edge router, so the edge router, it knows how to, it's directly connected to this segment, and this segment. So 3 segments are directly connected to the DHCP server, and it happens that these 3 segments are point-to-point links, so it doesn't make a difference. But this DHCP server does not know nothing how to reach. It does not know how to reach these segments 172.16.0.0 and 172.31.0.0. So it does not have any clue how to reach this segment. So if we check its routing table, show IP routes like this, do we have information about 172.16 and 172.31? No, which means that we have to go to this router and we have to configure it with a static route. So we should teach this router, if you receive anything, if you want to send anything to segment to network 172.16.0.0 with subnet mask, okay, just forward it to the next hop IP address, which is 10.0.0.1. okay, as simple as that. And if you receive anything for packet, if you receive a packet intended to network to a host or device on network 172.31.0.0, then of course you have to forward it to the next hop IP address 10.1.1.1. okay, so this is clear now. So let's check our routing table. So let's check our routing table like this. Yeah, we have now these 2 routes. Now edge router has been configured to forward the packet destined to network 172.16.0.0 through this next hop IP address 10.0.0.1, and any packet destined to network 172.31.0.0 should be forwarded to this next hop IP address 10.1.1.1. So as simple as that. Now let's see what happens. Let's see if this works. So I go to host 1, okay, make it static, and then DHCP. Okay, you see now things work fine. Host 1 was able to acquire IP address from the DHCP server, as well as the subnet mask and default gateway. And host 2 also, let's see what happens. Host 2, yeah, is going to request an IP address, was able to acquire an IP address from the DHCP server. So what we have done, we simply configured RT1 and RT2 to act as relays, and whenever they receive broadcast packet, they should forward them to the DHCP server. Of course, the DHCP server does not know anything about network 172.16 or network 172.31, from where these packets are coming, from where these requests are coming. That's why edge router should be also configured with static routes to point to this particular LANs. Now, what we need to do also, edge router, it knows about this and this. Now, what about RT1? If I am now host 1 and I want to reach host 2, host 2, I think the IP address was 172.31.0.2. okay, okay, it is that. So you see, from host 1 I'm not able to reach host 2, and also from host 2 I can't reach host 1. Host 1, I think the IP address was 172.16.0.3. So the IP address that it obtained from the DHCP server. Exactly. So what is missing? It's missing static routes. Also RT1, if we go to RT1, RT1 does not know how to reach segment 172.31.0.0. Does not know anything about it. So we have to tell RT1 how to do that. So I configure a static route until RT1. If you receive a packet destined to network 172.168.1.0.0 with the subnet mask 255.255.255.0, just forward it to the next hop IP address 10.0.0.2. Now this router, this is the IP address of serial 000 interface of the edge router, and then the edge router will be in charge of forwarding the packet to the destination. Okay, and also we will do the same thing on RT2. So RT2, since we need to configure RT2 about this. If you receive a packet destined to remote network 172.16.0.0 with subnet mask, okay, just forward it to the next hop IP address that you can see, which is that you can reach. It's 10.1.1.2. Now it's very important to understand one point here, is that when you use next hop IP address, this IP address should be directly reachable from RT2. It should be viewed directly from RT2. I mean, you should not use this IP address serial 000 IP address 10.0.0.2 as the next hop IP address from the point of view of RT2. No, RT2, with respect to RT2, the next hop IP address should always be IP address of the neighboring router, which is directly connected to it, which is in our case 10.1.1.2. Now, since I configured that, now let's check if RT2 can communicate with host 1. Okay, if host 2 can communicate with host 1, you see now it's working. And we can always use a trace route to check the reachability between okay, so how many routers we're going through. So in order for host 2 to send a packet to host 1, it should cross default gateway, which is 172.31.0.100. Then it should go to the next router, which is 10.1.1.2. It will reach the third router, 10.0.0.1, okay, and finally it will reach the target, the destination. And the same thing on host 1. We can try and see if host 1 can reach host 2, which is at 172.31.0.2. Okay, okay, I typed this, but it will be something like this. It's much safer. Okay, so we see now the same number of routers. So host 1 is able to reach host 2 by forwarding packet to the default gateway 172.16.0.100. Then the next router 10.0.0.2, then 10.1.1.1, then the default, or let's say the target, the final destination here, which is 172.31.0.2. So everything is working fine. Now, still that if I want host 1 to communicate with the web server, which is at 192.168.0.1, let's ping here, ping 192.168.0.1. The destination is then reachable as well. Why? Because router RT1, RT2, they both don't know how to reach this destination. So let's continue configuring these routers. So the first thing I will do, I will go to RT1 and say, okay, IP route. I have to teach RT1 how to reach this segment here. So whenever RT1 sends a packet to this segment 10.2.2.0 and the subnet mask is 255.255.255.252, it should simply forward the packet to the next hop IP address 10.0.0.2, which is 10 like this. Okay, and then we have to, same thing, we'll do the same thing here. We will tell RT1 that if you want to reach network 192.168.0.0/24, 192.168.0.0/24, which is a subnet mask, simply forward it to the next hop IP address 10.0.0.2, which is the next hop IP address, the IP address of the neighboring router. Same thing, and I will do this with the other LAN, remote LAN, which is 192.168.1.0. Okay, so we have always to use network addresses. In this case, basically, we're using the network addresses. Okay. All right. So now we are done. Let's check our routing table. Show IP route, and we can always filter this by displaying only the static routes. So how many static routes we have? We have 1, 2, 3, and 4. So it means we teach RT1 how to reach this segment here, this segment, and this segment. So we have 3 remote networks. So with respect to RT1, there are 3 remote networks that should be configured through routing protocols and routing table in order to be reachable. I do the same story with RT2. So I will teach RT2 if RT2 wants to reach segment or network 10.2.2.0. The subnet mask is 255.255.255.252. So just send it to the next hop IP address 10.1.1.2. Okay, and the same story. If RT2 wants to reach this segment here, IP route 192.168.0.0 with the subnet mask, just send it to the next hop IP address 10.1.1.2, because we know that for RT2 to reach this segment here, it should always forward the packet to the next hop IP address, which is 10.1.1.2. Okay, and do the same thing with the other LAN, remote LAN, which is 192.168.1.0, and the same next hop IP address. So now if we check show IP route, I display only the static route, and I can see that there are 4 different static routes, which means that RT2 now knows how to reach this remote network, this remote network, this remote network, and this remote networks, those networks which are not directly connected. Maybe we have to add another route. So I am in RT1. I go back again to RT1. There is a network that I forgot. I have to teach RT1 how to reach this segment here. So I can go to I can do the same thing. If I want a router to reach every possible network, so I tell him, if you want to reach network 10.1.1.0 with a subnet mask 252, just send it to the next hop IP address 10.0.0.2, 10.0.0.2. Okay, right? And same story with RT2. So I'm telling RT2, if you want to reach this network 10.0.0, okay, 10.0.0.0 with the subnet mask 255.255.255.252, just send a packet to the next hop IP address 10.1.1.2, which is like this. All right. So now how many static routes we have? We have 1, 2, 3, 4, and 5. So from RT2, I have a static routes to this segment here, to this network. This static route to this network here. This static route to this network. Okay, and this static route here to this network, this network. Okay, and this static route here to this network, which means that how many remote networks with respect to RT2? We have 1, 2, 3, 4, and 5. By remote networks, I mean those networks which are not directly connected to RT2. So that's why we have 5 different static routes. And how many remote networks with respect to RT4? We have 1, 2, 3, 4, and 5. That's why you go to RT1 and you can see 5 static routes. Now, what else? I already configured the edge router to. I already configured the edge router with these 2 static routes, 172.16.0.0, 172.30.1.0. So I just need now to teach the edge router how to reach these 2 LANs here. One IP route, 192.168.0.0 with a subnet mask. Okay, next hop IP address should be 10.2.2.2. Okay, and I do the same thing for the second LAN, 192.168.1.0. Okay, subnet mask 255.255.255.0, and next hop IP address 10.2.2. So now, with respect, let me just display the routing table, just static routes on the edge router. How many static routes we have? 1, 2, 3, and 4. So, how many remote networks with respect to the edge router? So the edge router has the following remote networks: 1, 2, 3, and 4. So this is a static route to network 172.16.0.0, which is reached by sending packet, forwarding packet to next hop IP address 10.0.0.1. This is another remote network 172.31.0.0, which is reached by forwarding packet to next hop IP address 10.1.1.1. This is another remote network 192.168.0.0. Packet can be forwarded to next hop IP address 10.2.2.2 to reach destination, and a next hop IP address here, and another destination or remote network 192.168.1.0, which can be reached by forwarding packet to the next hop IP address 10.2.2.2. So we have 4 different static routes on the edge router. Now let's go to the ISP router. ISP router, it's very simple. I can do this, show IP route, and of course there is no route already configured, but only those directly connected. So we have 3 directly connected. We have the 10.2.2.2.0, 10.2.2.0, we have the 192.168.0.0/24 and 192.168.10/24. So there is no other routes connected. So what we do now, how many remote networks with respect to router ISP? Remote networks, we have 1, 2, 3, and 4. Now instead of doing this with respect to ISP, I can simply configure default gateway. Okay, I see. IP route, sorry. IP route, whenever you receive a packet destined to any network which is not shown here in the routing table, just use this default route. I mean, last solution, use this default route. Okay, and you send it to the next hop IP address 10.2.2.1, which is 10.2.2.1. So this is the meaning. Whenever ISP receives a packet from web server 1, web server 2, and this packet is targeting a network which doesn't show in this routing table, so the router is going to rely now as a last resort, it will rely on the default route, and default route basically it will forward any packet with unknown destination with respect to ISP to this next hop IP address. Hopefully this next hop IP address is the IP address of the edge router, which will take care of sending the packet to the right destination. So let me just do it like this. Now I'll display the routing table. Okay, show IP route, and what you notice, default gateway always have this star or asterisk here, which means the candidate default. So this indicates the default route. So any packet sent to destination to network, and this network is not available, is not shown in the routing table or explicitly identified in the network table, in the routing table, sorry. So the router is going to rely on this default route as a gateway of last resort. This is last solution. This is last thing. This is the only solution that the router can use in order, and it will forward the packet to next hop IP address 10.2.2.1, which is the IP address of the edge router. Now we have we can say that static route, and we just augmented this by default static routes. Okay, so the default static routes, you use it whenever a particular route is not explicitly shown in routing table. So just configure something like this: IP route 0000, any network, okay, and subnet mask 0000, and this is next hop IP address. Now, moment of truth, let's check if from host 1 I can reach the web server. I can ping the web server, yes, no. Okay, let's see what happens. So generally it will time out maybe. Okay, and then we see there is a reply. There is a reply, so everything worked fine. I can also rely on trace route to do this check. Okay, it's much better like this. So I will see my default gateway. Now this is the second router, 10.0.0.2. This is the edge router, 10.2.2.2, which is the ISP router, and finally the destination. I can do the same thing with the other server here, 192.168.1.1, okay, which is also reachable. Okay, it takes some time, but it works at the end. So I can do the same thing from host 2. Okay, so it is repetition, but it's okay. So I trace route to 192.168.0.1, okay, and I trace route to 192.168.1.1. It's okay also, so I can reach this. Not only that, you can choose any point. For example, this IP address 10.2.2.2. Okay, I can trace route to 10.2.2.2. Okay, all right. So the idea is to make sure that any point can reach any point on your inter-network system. Make sure that routing tables are configured correctly. This is the most important thing. Now, to come back to the DHCP server, I would like to know how many IP addresses are leased. Okay, just show IP DHCP. Now we see how many options. I can check the binding. So from the DHCP server, I see that 2 IP addresses have been assigned. Of course, if I want to know 172.16.0.3, I know that this is host 1 because I have only one computer, but I can always rely on the MAC address to identify the computer, and this is automatic assignment, which means dynamically assigned. Of course, the DHCP configuration can go from simple to more complex to very complex. Here in this example, we have seen a very simple example. I can also see other options from the binding, which IP address was assigned to which host. I can see also the pool of IP addresses, so you can know exactly how many IP addresses are leased. 1 IP address leased, how many IP addresses were excluded, 2 IP addresses excluded. Okay, so I can see the range. So you can do this as an example here. This is the first pool. So this is the subnet size. Total addresses, we have 254 addresses. Leased address only 1. Excluded addresses only 2. The one that I excluded previously plus the one which is already assigned. 1 subnet is currently in the pool. Okay, so this is the range of IP addresses. 1 leased, 2 excluded, and the total IP address defined in the pool is 254. The same thing here. So let's see other option. There is no conflict. There is no conflict basically. For RT1, show IP DHCP relay. Okay, for this there is no such information is not applicable. Okay, it's not applicable here. Let me just display here. Show IP DHCP relay information. Okay, this command also is not applicable. Anyway, at the end, what we have seen in this, to wrap up with this scenario, we have seen how to configure the DHCP server on a remote network, and then how to configure routers as relay in order to be able to forward the DHCP messages to the DHCP server and establish connection between, or let's say establish communication between DHCP client and DHCP server for the purpose of acquiring dynamic IP addresses dynamically. We have seen also static routes. We have used a good example of static routes, and at the end we have seen also an example of default static routes. Again, remember, default static routes is used whenever destination IP address or destination network or remote network is not explicitly seen in or available in the routing table. So just use a default static route in order to forward the packet to destination network if it can be reachable from the next hop router, which we'll try to see other example of default static routes in other scenario. Thank you for viewing, for listening. See you in another video.